Hello friends, welcome to my channel. So as you know that in last video we discussed the relationship between differentiation, machine learning and computer vision. So my today topic will be first order partial derivative and chain rule and how these two topics related to actually this is not two topic derivatives and I mean when we talk about chain rule then it's about the differentiation also only and how it's connected with machine learning plus computer vision. Okay, this will be our topic. So first let's consider this equation that I this is suppose this is a mathematics normal mathematics equation. Loss equals to w1 minus minus 3 to the power whole square plus w2 minus 1 to the power whole square, to the power 2. So this is a simple equation, and here you can see that if I go to differentiate loss with respect to actually here W is weight. So if I go to differentiate this loss with respect to W1, then this will be 0 and the error will be something else. I mean the change will be something else. And if I go to differentiate this loss with respect to W2, then there will be some different value. I mean the effect will be different. So it depends on the you can say the path or the parameter which you are going to provide here. Normally we have already talked about the machine learning and about the differentiation, and whatever we have discussed, this was the first that was the first order partial differentiation, that means the okay, first order differentiation. That means the power I have, maybe I have told, yes, yeah, I have told that if divide by dx, we are doing divide by dx, then it will be first order. And we are going for d2i by dx2, then it will be your second order differentiation. So we have discussed the first order in last video, and let me tell you that it depends. If you are going to differentiate it with respect to W1, then loss will be different. If you do the same thing with respect to W2, then loss will be different. So loss depends on both W and W2. That means the both weight are very necessary, and it depends on the both weight, which is W and W2. Okay, this was something. And if I do a program based on, then let me write a program called, if I'm going to write a program, sorry, wait a minute, loss, if I am giving a I'm defining a function which is loss, and I'm taking two parameter which is w1 and w2, that means weight 1 and weight 2, then it will return you the same thing that I have passed over here, that means this one. It's going to return you, not this one, actually this one, to this. It's going to return, this will be you, you will get it. Okay, and now again I'm creating a function called grade underscore w. That means I'm going to differentiate it with respect to w1. Then what will happen? Then it will return you, and I will tell you how it's working, how it's happening. Okay, and okay, let's talk about the first one. Mm. So this is my equation, and if I go to differentiate it with respect to w1 only, then what will happen? This w2 will be considered as constant, so it will be zero. This will be completely zero. So only the derivation will work on it. Okay, because this here we got the w1, so this 2 will come in front. Okay, and then that's why it's giving me 2, which is at the beginning, and then w minus 3. This will be the simple thing which we have already understood over here. The differentiation point. Wait, let me show you. Yes, this one. So constant will be 0 and x would be 1. So why x would be 1? Because the power of x at the, I mean the power of x is 1. Okay, this is first order derivative. So power is 1. So actually not about that. Okay, let it be. Then this one will come in the front, or if I can say that I can give you an example with this one, no, about the in the maybe in the image I have shown you, no, the picture. Okay. Mm-hmm. Let it be. So if I take y equals to 2, y equals to x square, then the power of, if I, let me write over here. If I go through it, let me give an example over here. If I have y equals to x to the power 2, and if I differentiate it, then what will be happen? The dy by dx would be the 2x. And how it's happening? Because this 2 is going to come in front, or in front of x, and then we will minus, I mean from 2, 1 will be deducted, and there will be only 1x left. So that's why this is 2x. Okay, the same manner this will work, and this 2 will come here, and now 2 minus 1. Whenever we do differentiation, the simple thing we do what is we subtract 1. If I proceed for differentiation with respect to that variable, then it will reduce its power by 1, and then whatever will be there, I mean left, it will show you. I mean, if I take y equals to x to the power 4, then if I go to differentiation with respect to x, then the answer would be dy by dx equals to 4 will come in front, and the power was initially 4. Now it will reduce by 1. Then the answer would be x 4x cube. Okay, so try to understand that every time when you will differentiate, the power will reduce by 1. Okay, so here also the power was 2, but right now 2 come here, and then it's working like this. So the same manner we can do go for def grade. Grade is nothing but differentiation. We are doing differentiation over here. So this will take. Oh, I didn't take any parameter. Oh, sorry. I forgot to take the parameter. This parameter will come over here. Why I'm doing this? I can write it now. I will do. Okay. So it will return you. So it will return you this one. That means 2 into W2 minus 1. This will be your answer. So each gradient tells how to move that way. I mean, if you want, I mean, there's maybe if you put some value over here, and then you can calculate it, which path is giving you less, or yes, less error. So you can go with that path. Okay, you can use that differentiation. So now let's talk about the chain rule. Why chain rule is needed? Why we need chain rule? Chain rule is nothing but it's I mean, you can say that function of function. I mean, chain rule describes that you can do something like, let me write over here. Let me give an example. So suppose I have y equals to sine sin x 2. Okay. So have you understood what I'm going to say? We know that sine is itself a function, and we have passed our x square over here. So this is going to take another function. I mean, we can do it, we can say like wait, let me give comment out over here. And if I go to write, suppose I'm writing over here that u equals to x square. So now it's easy to understand. You can see that this is a function, this is a function, okay, and I'm putting this function into another function which is sine function. Okay. So, chain rule helps you to understand, I mean, or to hold a function within a function. Or you can say, yes, see, this is the right thing. Okay. So, it will do what? It will hold a function. I mean, it can be like something called, let me give an example, another example. So, it can be function of g x equals to function of, oh, I didn't give the equals to function of y. It can be like this one. That we know that g of x is a function, and function of g of x is another function, and this is holding. I mean the value is function of y for of all this function. I can give you a good example also. So what you can see is the chain rule is a formula used to compute the derivatives of a composite function. That means, what is composite function? So a function inside another function is known as the composite function. So this is nothing but it's a formula, so that we can hold a function into another function. Hmm? Like function of g of x, this one that I have given you the example. It tells us how to calculate the rate of change of one variable with respect to another when there is an intermediate variable connecting them. So I want to give you an example. Suppose you walk at a speed of 1 kilometer, okay, per hour, 1 kilometer per hour. Or let it be, okay, let's start with some other point. I mean, with some other approach. So, suppose there is a car, and its speed is something you can, whatever you can imagine. And this speed, the speed of the car is double of a bike. Just suppose that the car of the, it's a race car. So, the speed of the race car is double to a bike, okay? So now this bike has 4 times more speed. I mean, this is 4 times more faster or 4 times faster than you. You are walking, and whatever is your speed, it's 4 times. The 4 times of your speed is the speed of bike, and the speed of bike, the 2 times of the speed of the bike is the speed of the car, race car. Okay. So as you can see that these are interrelated. Okay, so you can consider as that your speed is 1, then the speed of bike will be 4, and then the speed of the car would be 8. So this is the way we use chain rule to connect each other and to find the solution based on that. Okay, so let me um, derive this. If I go to differentiate then what will happen? First, I need to differentiate it one. So if I do this, then what will happen? Dy by dx equals to, at first, it will start with the outer side. That means I will first differentiate the last outer function, which is sine. So the differentiation of sine will be cos. Okay, so this will be your cos function, and the thing which is inside it will be same. Okay, because this is another function, I'm not going to touch right now this one. And then I'm going to differentiate. I mean, in the first time I will differentiate the outer function, which is sine. In the second time I will differentiate the inner function. So right now I'm going to differentiate the inner function. So the inner function would be what? We have x square, so it would be 2x. It would be 2x. Okay, this is your answer. So now it will be equals to 2x cos of x square. This is the complete answer. And in the same way, chain rule works. Now let's talk about chain rule, that why chain rule is needed. So in the real life machine learning, this is not a one step. Means, let me give you the example over here, and it will be easy to understand. So suppose I have Z equals to weight into X. Okay, this is my one equation. The second equation would be Y equals to Z into Z. This is my second equation. And the third point, which is loss equals to Y minus 10, and then square. So what you understood, that I have a Z which is taking nothing but W into X, that means weight into one variable. And the second one, I'm putting this value of Z. I mean, this is my first, you can say this is my first function. Okay. This is my second function. Now I'm going to use this function, and I'm going to define it to the loss. I mean, the value would be, the loss would, to get the value or to the changes, I have to differentiate, and this will be done by chain rule, because we are working with two functions. You can do with some other function also, like 3, 4, 5, 6, 7. But initially we are doing it with two functions. That means this one function is inside, I mean, this is going, w y is going to hold this function, I mean this y function is going to hold the z function, and this loss function is going to hold the y function. So indirectly it's using chain rule. Okay, so, and the loss depends on y, and y means this loss will depend on y, because you here you can only see y, and this y it depends on z, and this z, because if we go to differentiate y, then the answer would be in z, or I mean with respect to z. You can see in the in this way also, that if you're going to differentiate this loss, then what will you do? You will simply write, no, suppose this loss as L, then dl by dy, because you have to differentiate with respect to y, then that means the loss is depend on y. And if you want to work with this y, then you have to differentiate y, and here it will go dy by dz. So the answer would be your 2z. Okay, so that means this, the value, the loss you can say, or the y is depending on z, and this z is again depending on w. I mean, again, not back. If I am go to back calculation, then this z is depend on w. So that's why we need to use chain rule. This is very needed. I mean, it's in real life machine learning, or we need chain rule. Otherwise, it will not. You will not be able to calculate the error, which is very. I mean, it depends on some other variable. Suppose you have 3, 4, 5, 6 variables. Then how will you work with it? So you have to use chain rule over there. So I hope this is clear. I just try to make you understand in an easy way. It can be complex. If you want, I can do it more complex. Now let's talk about the computer vision. So in the last video, we have already discussed that images are nothing but numbers, that means the pixel. And CNN changes CNN, which is what? CNN is nothing but this one. Okay. Yes. Convolutional neural networks. Okay. So CNN changes those numbers, which is coming from pixel, I mean, initially. Okay. And then loss. I mean, if we use machine learning, then it will predict, and prediction can be wrong. Suppose you are predicting that this is a image of dog, but it's actually a image of the cat, so there is a wrong prediction. Okay, then what will happen? Chain rule will work there. Chain rule will send error backward. Okay, I mean, it will go back. First this function will work, I mean this function will work, then again, actually this is, you can say that the back programming. I mean, you are going back to the uh, point. So from here you will start, and again then you will go here, and then you finally come to this point. Okay. So chain rule sends error backward. Partial derivatives update. Actually, whatever we have discussed in the first video, it was about the partial derivative. Okay. So partial derivative updates the filter. Updates filters. Okay. That's how CNN learns edges, face an object, and then it will, you can say, then in this way you can minimize your errors. Okay. Why you need this in program? I mean, why we need? So partial derivatives are calculating your, that means you can see that partial derivatives, your chain rule, which with the help of chain rule you are very comfortable to solve your to minimize your errors and to solve a big function. I mean, a function within a function within a function, like this, something like this. So you can, it will easy to handle machine learning, computer vision with the help of chain rule. Okay, so this is all about this video, and the next video I will come with a fresh topic. Thank you very much, and stay happy and healthy and keep practice.